Section 10.3 is usually considered a very easy day, but it is, just like all of our other skills, a critical day for understanding certain things in calculus. With this in mind, things like the inverse and then a few things called derivatives can't be done unless you have gone through what are called composite functions. Now, in the PDF notes, I've bypassed a little bit of the writing because you can see it in front of you. Composite functions are functions that are formed from two functions, or it could be more. And what's happening is the input of one function is being used, okay, as a value for another function. This is what it's going to look like. And I know it looks weird. It could be something like f of g of x or g of f of x. And this is another way to write it that many major textbooks do. The PDF notes don't quite show it. There's a little open circle there, very small, not even a zero, not an O, just a little circle. Now, what does this actually mean? How do you do this composition of functions where you're shoving one thing inside another? There's two ways to do it. And what I like to do, opposite of what many textbooks do, is I like to start with a known value. So here's how we're going to begin. Let's say you had three functions. F of x is 3x, g of x is 2x minus 1, and then h of x is x squared. You start to see now why we don't just go y. You start to realize f of x or even other letters are good, because if you just call them all y, well, which is which? Do you want y to be this line, or this parabola? That's why you use different letters. You start to see the power of calling things f of x and g of x and so on. Now, here's how we begin. Let's say you were supposed to say, what is f of g of 2? You're supposed to make this as a final computation. This is very simply the idea. What we are going to do is start on the inside. G of 2 simply means take 2 and shove it in for x. You guys, let's do the math in our head. 2 times 2 is 4, minus 1 is 3. G of 2 is 3, and now if you went back to number 1 in the notes, the idea becomes pretty obvious. What you're doing is you're saying, let's get this value, and then let's shove it inside the other function. So then what you're going to do is you're going to say, well, what is f of 3? Come up to f, put a 3 in for x, 3 times 3 is a 9. That's composition of functions with known values. Let's do it again so you get the hang of it. Let's say you're supposed to calculate g of h of negative 4. What you do is you start on the inside, and you're going to figure out, well, what is h of negative 4? So put negative 4 in, negative 4 squared is a positive 16, and then it's like really the input and the output. That is like the output, the answer, which now becomes the input for g. You're shoving that value inside a g, so you put a 16 here, 2 times 16, and then a minus 1 is a 31. And this is not just games. We're just practicing up for something bigger coming later, like all of our skills. Let's say you add g of 5, and you're like, what? What are you doing? Well, here's the idea. You take 5, you shove it into g. 2 times 5 is 10, minus 1 is a 9, and then you just shove it inside g again. Put the 9 in here. 2 times 9 is 18, minus 1 is a 17. That is composition of functions. Now, once people get there, where they kind of see that, yeah, you just start on the inside, and that answer, that output becomes the input for the next one, they get into a nice flow, and they don't mind this at all. They don't find it too hard. Now, the final part is when you don't do it with known values. We're not going to get numerical answers. We're just going to use pure equations. This sometimes makes people feel a little bit more uncomfortable. So for number 3, we first of all just identify some equations. We'll do some new ones. Let's say one function is a line, x plus 2. Another function is a cubic. And you can be remembering graphs of cubics. It's always good to remind yourself of what's going on. And then one more, we'll go h of x is a square root graph that's been shifted, that old wall and window. And then if we were going to do this without known values, let's say the question just said, what is f of g of x? What does that equal to? There's no value to solve. You do it in a little bit of a different process. Now, instead of starting on the inside and working out, here's how I recommend people do it. Start on the outside in f. F is x plus 2. Now, watch what I'm going to do. I'm going to write one thing and say something different. So f on the outside is x plus 2. Now, why did I not write x? Why did I just put a bracket? What we were supposed to do is shove g of x, whatever its equation is, into x. So right in this bracket, I almost didn't give myself enough room. We have an x cubed plus a 2x plus a 7. That is the name of the game. Now, if you wanted to be fancy, you could simplify this. The only thing you could do is add the 2 and the 7 to a 9. You rarely even get that opportunity. But that is what a game is, a composition of functions where you don't have a value. So let's see that one again, because this one does make people think a little bit harder than when you have a known value like number 2 in the notes. So let's say you were supposed to figure out what is g of f of x. And what that means is you're supposed to shove f of x inside of g. Now again, I'm going to do the same thing. I'm going to say one thing, but I'm going to write something different. Start on the outside this time, because you don't have a known value. What is g? Well, g is x cubed plus 2x plus 7. And I'm going to do a color change just to make this pop a little bit. Why would I just leave open brackets? What we need to do is take whatever f is, and it's not a number this time. It's an expression, it's a line, and we have to shove that into g. So wherever there is an x for g, we got to shove in f. So f of x is x plus 2. And we're done. Now what we are not going to do is simplify. Yes, you could cube this out, distribute this, combine your like terms. That's not the point. I mean, you can do it if you had to, but that's not going to be time well spent. So let's do our final example. I'll just squeeze it in right here. Let's say you had to do h. I'm going to put a little circle so we remind ourselves of that other technique. And then an f of x. What that really means is h of f of x. Please don't be frustrated. Just like when you're dividing, there's more than one way to show a divide. You can make it as a fraction or you can use a slash. This is just another way to show a composition of functions. And you'll see it many times before you're done math. So then what is this saying? This is saying let's take f and shove it inside of h. So I'm going to do my same technique. I'm going to write down h, and h is x minus 1. Why did I leave a space there? That is where I need to shove f. I need to put f inside of h. And again, if you wanted to, you could do a little bit of simplifying. That would be reasonable to do. Cubing this might not be the best time spent, but that is what doing composition of functions is. It's a very important skill to move into doing things called the derivative and then really fully understanding the inverse if you ever take a calculus course.